Hi, everyone. Good afternoon. Thank you for joining another Take30 with a data scientist. I'm Pam Askar. I'm Ironside's Director of Data Science. Today, we're going to be talking about data science best practices, specifically feature stores, what it is and how to build it. I just wanted to let everyone know before I start that if you go to our website and you look for where you register for the Take30s, we actually have recordings of all the prior versions, the prior sessions from block one, the first 6 weeks that we did. So if there are topics that you didn't get to hear and you always wanted to go back to, those are available now for you online. So before I get started, I always like to just remind everyone about Ironside's mission, which is to help our clients use data to make better decisions about their business. And we do that with over 20 years of experience in end-to-end data and analytics. So we have expertise and capabilities in every wedge that you see here on this wheel. Data science kind of sits across all of those and has a foot in each of these, right? We help our clients to build AI strategies, to design the pipeline and how they would implement it, to actually build and deploy it, and then to govern and manage those AI assets. So it's a very holistic approach that we bring to AI and to everything in data and analytics. So today, what I want to talk about is give you a sense of the data science processing and then hone in on feature engineering and talk a little bit about what that is and the traditional approach to feature engineering and the technical debt that it can accrue. And then we'll talk about feature stores. And specifically, I'm going to talk about Snowflake as a place to build your feature stores. And I'll wrap that up with some key takeaways. When we talk about what a feature store is, it's actually there's this aha moment like, oh, well, yeah, that makes sense, right? So this is probably the way that people do data science. And actually, it was only introduced by Uber just 3 years ago. So it's not really something that's been around for a while, but it is something that can accelerate data science drastically. So let's start at the beginning first. I just want to confirm that I'm sharing again so people can see. Good.
Yes, you are.
Okay, great. So this is a high-level view of the data science process, right? So first, you're going to do some data discovery, figure out where your sources are, and then you're going to jump into feature engineering. You've got to pull all those sources together, and this is kind of in the world of data wrangling and ETL work, but you don't know the end result, right? You're not trying to define or fill a predefined table. It's very exploratory in nature. You're creating features as you explore what data is available. You probably have a list of ones that you want to create, but it's a lot of data mining. Then you go on to machine learning after you've created these features. And ultimately what you need for machine learning is a final table with your target that you want to predict and all of your features, and everything's aggregated at the same level. So you go into machine learning, create a bunch of algorithms, train them, evaluate them. And this process is actually very iterative. You might go back to feature engineering and create some other features or change how you did them. Once you have your final model that you know is good, you move on to deployment. You're going to build some kind of pipeline to automate the flow of data through feature engineering, through the algorithm that you created to get a score and bring it right back to the business. And then you've got to monitor and retrain that. Now, feature engineering is one point on here, but this can actually make up 70% of the effort. So all of this effort really comes down to this part. And what are features and what is this process of feature engineering? Let's talk about that, but keep that metric at 70% of the entire effort in your head for when we talk about the traditional approach to doing this. So here's some examples of feature engineering and the features that come out of it. When data scientists talk about features, you can think of them as attributes, as predictors from different backgrounds, have different terminology for them, but really they're the fuel of AI. Right, you need as many features as you can, or at least you try to create them all to explore them to find what features are going to be predictive of your outcome. So you might do things like computing aggregate features to come up with the average purchase amount per month. That might be a feature when you're trying to predict when a customer is going to churn away from your business, or the max days overdue payments last year. That might be a feature in a loan default model. You might do some feature binning, like instead of leaving age raw, you might group them or create high, medium, low groups, for example. One hot encoding, this is a very mundane data data science task where you take a categorical field like physician type, and instead of leaving it categorical, you kind of transpose it and create a column for every category, and you just make that a binary 0, 1. Data science loves zeros and ones. Then there's other mundane tasks, right? Normalizing data, cleaning data. You may actually do some machine learning to create other features. So that's often done in dimension reduction. Say you sell 10,000 products and you think that the products your customers are purchasing might be predictive of, other products they'd be interested in, or when they're going to turn away from you, or price sensitivity. But 10,000 is a lot, so you want to reduce that down to, say, 100 types of them, right? So you can use machine learning models to cluster that if you don't have a topography. And then sometimes you need to do things like create polynomial features if there's some nonlinear effects in there. So this is just a sample of the types of engineering tasks that data scientists are going through as they churn through all that data. You might create 200 features or 500 features or 50 features, and it's very exploratory. In the end, you may use a fraction of those in your final model that you deploy. So Uber has said that data is the hardest part of machine learning, and it's the most important piece to get right. Modelers spend most of their time selecting and transforming features at training time and then building pipelines to deliver those features to production models. Broken data is the most common cause of broken problems in production machine learning systems. So let's walk through an example of how this is traditionally done and why it results in those kind of problems. The traditional approach to doing this is to build models in isolation. When I say in isolation, I mean isolation from other models and other use cases. So if we have model A here, we're building a pipeline for training, and we're creating, those are examples of 3 features, right? I just used shapes, right? So we have a circle, a square, and a triangle. Then I go and I built another model, right? So model A, that's great. We have another use case, and we're going to come in. We might be interested in using that same circle feature again. Maybe we don't know that it was done in model A because a different data scientist or data science team built it. Even if we know it's there, it's embedded in that pipeline, and it's built with the sample and the use case in mind for model A. So it's not easy to extract and reuse. And so what we're just going to do is go ahead and recreate it. And then we have model C. And again, we might use some of the features that were created in prior use cases, but we're going to build them again in isolation. And it gets even worse because when we move to deployment, the model C was good enough to be deployed. We actually have to recreate a whole nother pipeline, not just copy it over, because things are a little bit different in production, and recreate them again. So what happens here is a whole lot of technical debt. There's redundancy because you're recreating the same things over and over again. These features are embedded in those pipelines. They're not easy to pull out and reuse. There's also inconsistency and a lack of ground truth, because anyone knows who codes that there's 12.5 ways to code any single metric. And so I may program that circle feature one way and somebody else a different way. And who's to say that there's really ground truth and that we come up with the exact same result? So there's a lot of inconsistency there. And if you want to update any of those, you've got to run that entire pipeline to update any single feature. Google has called machine learning the high interest credit card of technical debt. So this is really how things are done traditionally. Now, the Googles and the Ubers of the world, they figured this out, that this is a problem, maybe around the same point when they've developed 3 models and deployed one. They said, wait a minute, this is not working very well. There's got to be a better way. And so you kind of have this class division, right, where Googles and Ubers and Facebooks of the world are building their feature stores, and they have that down, and it's very sophisticated. But every other organization that is growing in AI maturity gets to this point where they start to go, oh, this isn't working very well. And because feature stores are fairly new, they're not that well known. Every organization kind of has to figure this out and learn this and discover this problem. And that's not necessarily necessary, right? So, and that's one of the reasons I wanted to talk about this today, to say as you start to grow in a maturity, before you get to the point where you're going, whoa, this is way too much, we have a ton of technical debt here, you can think about how to set up a feature store to make yourself scalable long term. So the feature store is meant to be a holistic approach to machine learning. You're not thinking about a single use case, you're thinking about your organization being an AI-driven enterprise. And a feature store can be thought of as a data mart, where you're doing all of that feature engineering, storing it, and then you pull from the feature store what you need to do your training. And it looks similar to another data warehouse, right? You govern it with tables on topics. You might have a table with customer demographic features, with customer product features, with policy features, with claims features. And then when you want to go and build model A, right, you create these features, and as you create them separately, again, keeping in mind that you may want to reuse them someday, keeping in mind that you have this feature store, and you store them that way. When you come to build model B, you can query that feature store and say, oh, there's some features in here already that are going to be relevant to me, or that I can at least explore and test out. So I can pull those. As I create other features, I'm going to store them in there. And so this feature store is different from other data warehouses and data marts, I think, because you're not predefining, again, how big it's going to be and what's going to be there. It's exploratory, and it needs to scale and grow and be flexible. It's a very dynamic thing. And so for that reason, it's important to think about how and where you're going to build this. There are some commercial feature stores being released out there. So Uber has released theirs. They call it Michelangelo. They commercialize what they use internally. And there's a couple out there, but like I said, it's still fairly new. You can also just build them internally on your own system. Now, cloud versus on-prem, cloud wins hands down for that scalability, that ability to create tables, get rid of them, grow with each use case that you develop and not being held back. And for that reason, like I alluded to at the beginning, Ironside uses Snowflake. Snowflake is a strategic partner of ours, and it's our choice for our internal technical stack. 5 things I want to talk about why they're ideal for feature stores. One is the unlimited storage. So again, just needing that scalability, needing to work in an undefined environment. And the elastic compute, same thing, unless you pay for what you use, and just allows you that flexibility and scalability. Also, having dedicated virtual warehouses for teams and workloads is critical. You're not competing for resources. There's no bottleneck. You don't have to wait until 9 p.m. to run anything, so that you don't disrupt anything else that's in production. Data scientists can now work at the pace that they need to work at. And with data shares and data exchanges, again, they can pull data in and make copies very easily. They have everything at their fingertips. And it integrates with pretty much anything else you want to use. You can sit it on Azure or AWS. You can integrate it straight into auto machine learning tools like DataRobot. So it's very flexible and a fantastic tool to build your feature store on. So some other tips here for feature store development. Naming conventions and very mundane things like that become really important. You need governance and documentation. You need to know what exactly is in there, because like I said at the beginning, data science is very exploratory, it's iterative. And so the way that you create any of those features, again, if you think about that traditional approach, you're doing it with the context of that use case. And that use case comes with a sample. It's not everything in your database. It's, well, the last 2 years and this specific type of physician and this specific role, and filtering these things out. And so any limitations you put on that, you've got to make sure that you document and include in naming conventions. So you've got to spend some time thinking about how you're going to set this up and how you're going to structure it at the beginning, but it will save you a lot of time in the long run. The feature store is also a place to put target tables and training tables. So your target table is very similar to your feature tables, but it's what you're going to predict. It's your outcome, and those usually get set in its own table. And that training table is that final table that you want to use for machine learning, right? You can just store it in the same place, have its own schema. But the training table is, you have a column for your target that you're trying to predict and all those features. And again, you've kind of pulled those features as needed from a feature store, because they're all there, they're governed and documented. So some of the key takeaways here, again, feature engineering is a significant part of the data science team's workload. We spend, like I said, up to 70% of our time doing that. And doing it in isolation, every use case over and over again, comes with a lot of technical debt. And so that 70% effort can get scaled down and down and down when you use a feature store. So you get those economies of scale and that benefit of being able to reuse what you've already put into place. And I would highly recommend Snowflake. It really needs a cloud data platform to be scalable and to be flexible. It's ideal for that holistic approach to data science. So let me pause there and see if there's questions that I can answer for you on setting up your own feature stores. Like I said, I think it's something I've encountered that organizations, as they start to grow in AI maturity, will you kind of have to figure it out and say there's got to be a better way, and then you learn about feature stores because it's just not a very known topic, and then go back to the beginning and try to set up and redo a lot of that work. So we wanted to put that out here, so as you may still be fairly early in AI maturity, you can think about how to structure that and how to set it up so you can be scalable for the long run.
So you mentioned Snowflake and using Snowflake as your cloud warehouse. How would you compare Snowflake to something like Redshift in using it for that purpose?
Yeah, like I said, compared to on-prem, I would definitely go cloud. We prefer Snowflake. We find it cost-effective. We find it it's easier to manage the costs and also just faster. So it's more flexible. It's just a fantastic data science tool, I will say, for myself. I don't know compared to Azure quite as much, but I can say compared to Redshift, we found it beneficial.
Terrific. We have one more question, and hopefully other folks will ask a couple more. Do you store the final version of the feature even when you're using something like one-hot encoding?
Yeah, so that gets to some of the detail of creating this that I didn't go into. One-hot encoding is mentioned probably because it can take up a lot of space, right? So it may not be necessary to put in your feature store. What I do, and different people have different approaches to this, but I try to separate feature extraction from feature treatment. So I think they're both part of feature engineering. Feature extraction to me is, aggregating that value, so you have the average sales per month, right, or the max days overdue of an individual. So you get that. Now that field that you created might have outliers. It might not be normally distributed. It might be a categorical field that you need to do some one-hot encoding for. That I see as feature treatment. And so I extract it and I store it in the feature store. And then when you're trying to pull what you need, you can do that treatment, and you write kind of that second phase of scripts to do that treatment. How you treat a feature is often dependent on the sample you have, on the use case, and so that's why it's another good reason to save it. And one-hot encoding, just because it takes up so much space, there's no need to do that and put it in the feature store. So I hope that answers that question. And I see a couple others coming in. Which major companies use the feature store? Hard to say. I would say anyone who's really mature in it is definitely doing it. Like I said, Uber, Google, all of those clients I've worked with, all need to be taught about what it is, how to set it up, and so we've built it for them. I know Uber has released theirs, and there's a couple of private companies that have created and commercialized feature stores that you could purchase. Do tools like SPSS Modeler use or leverage feature stores? No, but so SPSS Modeler, the new version of that in Watson Studio, is part of the Cloud Pack, and so you could think about using the data catalogs as a place to govern and query those feature stores. I think that's kind of that next layer that you can put over a feature store is the catalogs. And so SPSS Modeler is a GUI tool to do all of the feature creation, but then where you put them is not included in that. So if you were using Watson Studio, I think you could integrate with the data catalog and use that to govern it, but you'd still, look to store it in that way for a feature store. It's not native.
Pam, I know you just mentioned the data catalog, and just for folks' reference, tomorrow's session with Talk to a Data Advisor is highlighting data catalog, and we work with multiple different data catalogs, but the one that's being highlighted tomorrow is Elation.
That's a good point, yeah. So you could hear about that. I think there's layers of a feature store, another detail I didn't quite get into, but yeah, that governance and management of it, a data catalog would be fantastic to put over top. Let's go back. Oh, I can say here, so what I was saying about separating feature extraction from feature treatment is kind of these two phases. So in feature engineering, you're pulling your sources, you're doing that aggregate, you're creating those features that you sit in the feature store. And then sometimes we save the treatment of those, treating the outliers, normalizing the data, doing the one-hot encoding for training. And so you'll have another set of scripts here that kind of pull those features that you need, look at them within the context of the use case, make some decisions about treatment, create that table. Now, when it comes to deployment, you may have created 200 features, but your best model really only needs the top 50 of those. So you don't have to go through this whole engineering process. Again, you will pull what you need from the feature store, apply that treatment, but in a production type of pipeline. So just to clarify that point. And again, so back to the example of SPSS modeler. So I've done that a lot, and you'd have a stream or several streams would be the single pipeline that you're building, right? And everything's kind of downstream from everything else, and so you can't just pluck out how you created any single feature. But if you were thinking about this in terms of building a feature store, you could still use SPSS modeler, but you would have it in mind that that's what you're doing, and so you'd create feature by feature and store it in there, have a completely different set of work streams that would pull together what you need and treat them.
Terrific. I don't see any more questions, so I think that sort of wraps up our day.
Great, thank you so much. Look forward to talking to everyone next week.